Yeah, sorry about that delay. I wanted to hit record because I want to eventually create some videos from these lectures so that if you'd like, you can go watch them later on. Yeah, so descriptive statistics and inferential statistics, very similar to begin with, but then we infer, and that's what statistical inference is all about. We infer from the small sample to the larger population. You know, for example, we might calculate the, say, the average salary of a group of college students, let's say. And to do that, we take a sample size of, let's say, 100 Delta College students, and we want to infer from that 100 to this larger N, which is the population size. And maybe, you know, what do we have here at Delta College? Maybe 12,000 students. So we're taking a small sample of 100 from the larger group of 12,000. And maybe the sample mean that we calculate here turns out to be, say, $20,000. And it's easy to get data from 100 people. Well, certainly it's much easier than getting data from 100 people than 12,000. So what we do is we calculate the sample mean, and we really don't know what the population mean is. The population mean is a number that describes the population average, in other words, and we don't know what that is. But we can estimate it by using this result from the sample. So the difference between descriptive and inferential is in descriptive, we're just going to collect the 100 data values, and we're going to say, oh, based on these 100 data values, the sample mean is 20,000. We calculate that. We'll show you how to calculate that later on. But we're going to make a giant leap, and we're going to say, oh, because the sample mean is, the sample average salary is 20,000, that means that we're going to predict that the population mean is 20,000 as well, even though we don't know what that answer is. And it turns out if we do it correctly, and by doing it correctly starts off by taking a random sample, if we do it correctly, then we're fairly accurate in predicting this population mean about 95% of the time. 5% of the time we're completely wrong, but 95% of the time. So we're very confident in our estimate, and that's inference. Okay, continuing with the sampling techniques, there are two that involve groups, and that's where we left off last time, a stratified sample or random sample. And these first four all involve some kind of random process, random selection of individuals. And the last one is one that's used a lot, but it's not a random sample. It's a convenient sample. It's a sample that the researcher took because it was convenient to find those subjects to participate in the subject. So it would be equivalent of me saying, okay, I want to estimate the GPA of all the Delta College students. And so what I do is I just ask this class, what is your GPA? And you all tell me your GPA, and I calculate an average, and I say the average is 3.5 or whatever it is. Now, because you were not a random sample, you were selected just because you're convenient to me. You're all in my class. If I ask you to give me your GPA, you'll probably do it. And but when you don't take a random sample, you're less likely to get a result that represents the whole population. Okay, so that's kind of an overview of where we were. I want to then now go and just talk about these last couple. And so the first one is a stratified random sample. And in this one, groups are involved, but it turns out that groups are already formed. And usually it's a small set of groups, and the groups are homogeneous. That means they're somehow alike in some way, alike on some characteristic. And let me give you an example. Let's say that we wanted to ask something about, do you believe in the afterlife? And we're going to somehow get a sense of what that is. Now, different religions believe different things. So if we wanted to ask that question, we should probably get some input from all the different religions. So what we would do here is we would break down all of the different religious groups in usually when they do studies, or a lot of times when they do studies, they break it down into the larger group of Christians that are not Catholic, and then the Catholics. All right, so let's say that we have our groups formed. We know we have a kind of a listing, and we know how many are in each group, and we know what the group. And here's how this stratified. We want representation from all of these 5 groups. So what we do is we take a random sample. Each of these are samples. And if we take, and generally we'll take the sample based on the size of the population. And so these sample sizes do not necessarily have to be the same, but it will give us representation of all of the different religions. And then we group all of those samples into one big sample. And this is how we collect our sample to do our work afterwards. And we ask the question, do you believe in afterlife? And then we have representation from all these religious groups. But the key point about this, sampling technique is that the random, here's sample 1, sample 2. The randomness occurs by taking these random samples from the individual groups and putting them all together to form one big group. That's the feature of a stratified random sample. And the fourth one is a cluster sample. This one also involves groups. And in this case, you have all of these already determined groups. And the group might be a classroom in a college. The group might be, an individual church somewhere. The group might be, everyone that eats at Applebee's or some other restaurant. But the groups are already formed. And then let's say, usually in this case, we have many, many, many groups. And, you can think of this in the restaurant example, that all of these little groups are individual restaurants. And so what we do here is we have all of these groups. And the example I'll use would be individual classes at Delta. This is how we do the student survey every year at Delta. What we do is instead of doing a simple random sample where we would randomly select individual students from our database and then send them either an electronic or a mail survey and ask them to fill out the survey and return it. You know what our response rate on those are? Not very big. So it might be 10 to 15% of students who will return those surveys. So it's not a very good way to collect data. But the cluster sample is what we use here at Delta, and here's how it works. You have all of these individual classes, and what happens is individual classes are randomly selected to form the sample, but whole groups are selected randomly. And then everyone in those groups, so we have individual groups, think of these as individual classes, and then what they do is they randomly select entire groups, which means in this example, they randomly select entire classes. So if our class was randomly selected, then everybody in the class of the randomly selected groups would then participate in the survey. And we get much better response rate in this way because the professor has all the surveys, hands them to the students take 20 minutes of class time while the professor is doing nothing, just for the purposes of filling out the survey. And so the student has two choices: just sit there and not fill out the survey for 20 minutes, or just fill out the survey. And when we do it that way, most students will fill out the survey, and we get a huge response rate, and we get the data that we're after. But the key here is that we're not taking random samples from each individual group. We're selecting entire groups, and all of the students in those randomly selected groups form our big sample. That's the difference between these two sampling techniques that involve grouping. All right, and I mentioned something about the convenient sample, which is not really a random sample. So, all right, well, that's it. That concludes the 5 different sampling techniques. And of course, the 5th one is the convenience. The handout that I gave you, if you want to read a little bit more about this in the notes from Monday, here they are. And it goes through all of the different sampling techniques. And then here's what it says about convenience. Okay, let's take a look at a couple examples. And what I want you to do is to select one of the 5. You've got the simple random sample, or you have the systematic. The systematic, what you look for there is where you randomly select the first person and then select every 10th one after that, or every fifth one after that. Stratified, cluster, or convenience. Let me try to magnify this a little bit so you can see it better. There it is. Okay, let's kind of go through these. And in the section on homework in section 1.4, what they're going to ask you to do is they're just going to give you those 5 different choices and have multiple choice questions, and then they'll ask something like this. On election day, a pollster for Fox News positions yourself outside a polling place near her home and asks the first 50 voters leaving the facility to complete a survey. And these exit polls, this is one way that they can predict early who's going to win a particular state. They basically wait for voters to come out of the polling place, and then they ask them. Now, I don't know how this is going to work with all these mail-in ballots that are going to happen this year, but, and they ask them, who did you vote for? And they ask them a lot of demographic stuff as well, and then they can make conclusions based on those small samples that they're taking. The key to these is to try to figure out if and where the randomness occurs. All right, what do you think? Go ahead and type into the chat. Which of the 5? Okay, I think I think you've got it. Yes, this one is convenience because this pollster, it was just convenient to walk down to the local polling station and ask people. There was no randomness that occurred. The pollster didn't randomly select every 6th voter coming out of the polling place. They basically just asked the first 50 voters. And there's no evidence in what they've described in number 23 here that any randomness occurred. All right, what about number 24? Internet service provider. Oh, there's randomly. Okay, randomly selects 15 residential blocks in a large city. Surveys every household in those 15 blocks to determine the number that would use high-speed internet service. So there's my neighborhood. And there's the blocks. Now, what are they going to do with those neighborhoods? All right, go ahead and enter what you think the answer is for number 24. There is randomness, and some of you indicated like a simple random sample. And for a simple random sample, basically we're going to be selecting one at a time. We have a listing of everyone, every resident on the internet company, and we're going to randomly select from our listing of all of the folks that we provide internet service to. We're going to randomly select some. In this case, we're looking at 15 blocks, and they're going to randomly select whole blocks. You know, maybe it looks something like that. And they randomly select these whole blocks, and then everybody in these blocks are then surveyed to find out if they have internet service. So the randomness comes in selecting these random groups and asking everybody. So this is equivalent. This is another example of the cluster sample. Each one of these individual pieces here is not a class in this example, but it's an individual block. Block 1, block 2, block 3, block 4, all the way to block 15. And then they randomly select whole blocks, and then everybody is asked the question about internet service from the block selected. This way they only have to go to 5 or 6 different blocks and then ask everybody if that's what they're doing. Okay, so this one is a cluster. Take a look at number 25. 35 sophomores, 22 juniors, 35 seniors are randomly selected to participate in a study from 574 sophomores, 462, and so on at a certain high school. All right, go ahead and enter into the chat. Which one do you think this is? Okay, so it sounds like the answer that you're coming to is the stratified, and that is correct. And the reason here is that all of these groups are already determined. We've got the group of, here we have the religions broken down, but in this example we have freshman, sophomore, junior, and senior, 4 groups, and then we take a random sample from each one of the groups so that we have representation of all of the classes of students at the high school. We can make sure that in a simple random sample, you might get way more seniors than you do freshmen if the sample is not representative. It might not be representative. But in this case, we're going to select a small sample of sophomores, a small sample of freshmen, juniors, and seniors, and then add up all those small samples, and that creates our big sample. Yeah, so you were right there. And finally, the last one, number 26, officers for the Department of Motor Vehicles pull aside every 40th tractor trailer passing through a weigh station. Which technique is that? Go ahead and enter that into the chat. And we started with the 12th for an emissions test. So the 12th big truck got pulled over, and then you add 40 to that, so the 52nd truck would be pulled over, and then you add another 40, the 92nd. Yeah, this start with one and select every 40th. Because the first one was randomly selected to be the 12th, we do have a systematic random sample here. All right, so the only one we didn't do in this set here is the simple random sample. But, okay, these problems here are from section 1.4. So as I mentioned, when you go to that section, most of the problems will just be, 5 option multiple choice questions, and you just read a scenario like this, and then you select the right one, the one that makes sense.